Hello, everyone. Welcome back to our channel. If you're new here, I'm your name, and today we're diving into a fascinating concept in the world of artificial intelligence, latent space. Now, I know what you might be thinking. What on earth is latent space? Don't worry. By the end of this video, you'll not only understand what it is, but also why it's so important in AI models. So, let's get started. But first, let me ask you a question. Have you ever wondered how AI can generate images, music, or even text that seems so creative and original? What's happening behind the scenes that allows machines to understand and create? Let's break it down. At its core, latent space is a way of representing complex data in a simplified format that still captures the essential features of that data. Imagine you're trying to understand a three-dimensional object, like a cube. Instead of trying to visualize every angle and edge, you can represent that cube in a much simpler way, let's say, with just three coordinates. This simplified version is what we call a latent representation. In the world of artificial intelligence, particularly in machine learning models like autoencoders and generative adversarial networks, latent space plays a crucial role. When we train these models, they learn to compress vast amounts of data into a lower dimensional space. This space is the latent space, and it's where all the magic happens. Let's take a closer look at autoencoders. An autoencoder is a type of neural network that learns to encode input data into a lower dimensional space and then decode it back to its original form. Imagine you have thousands of pictures of cats and dogs. The autoencoder will learn to compress these images into a latent space where similar features are grouped together. So, in this latent space, all the cat images might cluster in one area, while the dog images cluster somewhere else. This clustering makes it easier for the model to understand the underlying patterns and features of the data. Later, when you input a new image, the model can quickly determine whether it's more similar to the latent space of cats or dogs, helping it make accurate predictions. Now, let's talk about GANs. These are another exciting application of latent space. GANs consist of two neural networks, a generator and a discriminator. The generator creates new data samples, while the discriminator evaluates them. The generator uses the latent space to produce outputs. For example, if you're using a GAN to generate images of faces, the generator can take random points from the latent space and transform them into realistic-looking human faces. What's interesting here is that the latent space can be manipulated. By moving through this space, you can generate faces with different attributes, like changing hair color or age, just by moving in different directions. To give you some context with data, researchers have shown that the size of the latent space can significantly affect the performance of the model. A well-designed latent space allows the model to capture the complexity of the data while remaining efficient. For instance, in a study involving image datasets, models with larger latent spaces were able to generate higher quality images but required more computational power. This balance is crucial in designing AI systems that are both effective and resource efficient. So, where do we see latent space in action outside of research? One of the most popular applications is in creative fields. AI art generators, like DALL-E and Midjourney, use latent space to create stunning visuals based on text prompts. By understanding the relationships between different visual features in a latent space, these models can produce unique images that blend various styles and concepts. In the music industry, AI algorithms analyze patterns in musical compositions, creating new songs that feel fresh yet familiar. These systems rely on latent space to capture musical elements like tempo, melody, and harmony, allowing them to generate compositions that resonate with listeners. So, to summarize, latent space is a powerful concept in artificial intelligence that allows models to simplify and represent complex data. By compressing information into a lower dimensional space, AI can identify patterns, generate new content, and even create art. Understanding latent space is key to unlocking the capabilities of modern AI and harnessing its potential in creative and analytical tasks. If you found this video helpful, please give us a thumbs up and subscribe to our channel for more educational content on AI and technology. And don't forget to leave a comment below. What aspect of AI are you most curious about? We'd love to hear your thoughts. Thanks for watching, and until next time, stay curious.